Linda. Eliana.
Miss Deidre.
Elite Eliana. Elite former Eliana. Yeah, but Paul Emma. So that's it. I will send a couple of vector questions, okay, in the group. I've sent it to some of you, but I'll forward it to the group so that the rest of you can also pick it. Is that okay? So you can try your hands at them. When the going becomes tough, you call me, right?
Yes, please.
Okay. Yes. My number sign rule so powerful. Erica. I'm coming. I'm being a standby. No, on. It's not. So, cosine rules so powerful, but they are limited. You can only apply them for. You can only apply cosine rule, sine rule for when you have two forces. If you have three forces acting concurrently on a body. So we have this point. We have force P, Q, and then maybe Y. Find their resultant and the direction. How do you do it? Let me give you this question. Let me give you a question which would apply this. Are you ready?
Yes, please.
Okay. Three vectors P, Q, and R. Three vectors P, Q, and R are 3 units due south. 3 units due south. 4 units due southwest. 4 units due southwest. And 5 units due east. 3 vectors P, Q, and R are 3 units due south. 4 units due southwest. And 5 units due east. Find by calculation the magnitude and direction of P plus Q. That's the I question. P plus Q. I. P plus Q plus R. P plus Q plus R, and I. P plus Q minus 2R. P plus Q minus 2R. So 3 vectors P, Q, and R are 3 units due south, 4 units southwest, and 5 units due east. Find by calculation the magnitude and direction of I, P plus Q, I, P plus Q plus R, I, P plus Q minus 2R. Can you take a bite? Can you take a bite? Carol? Nanette, can you try? Carol, Eliana, Mirabel, Nanette Mfua, Edubia, and Alcovala, can you try? Hey, Linda, okay, Linda too is here. Okay, I just want you to try I and I. Just try question I and I. Okay. As for I, you need a push. I know. So you just give it a try. The weather is not friendly. Let me check it out and be with you. Hey. Where they are? Come on. And you will show for Catcher don't know 5 money. Catcher don't know 5 money. Are you trying?
Stadia, please, is it due 3 units due south or due north?
For 3 units due south, 4 units due southwest, and 5 units due east. Right?
Okay, thank you.
Welcome. Okay. You have taken a bite. Let's look at it together. You see, so when it comes to where you have to apply two of the vectors, two of them, it can still be done by the cosine rule. Okay, so in the first situation, we are to calculate I, P plus Q. And we know the vector P. The vector P, it has a magnitude of 3 units due south. So this is north, south, east, and west. And the vector P is 3 units due south. So this is P. Its magnitude is 3 due south. Please, if you bring it here, you are not wrong. Okay. The most important thing is that the vector P is going to south or pointing to south. So whether it's from here, from the north pointing to south, or it's here, it's still south. Are you fine? Then for Q is 4 units south of west. 4 units. So south of west divides the quadrant into 2 equal parts. Okay, so this is south of west, and once it divides the quadrant into 2 equal parts, this is 45 degrees, and this is 90, making the total angle between the two vectors P and Q to be 135 degrees. That's one way you can solve the question. Okay, so the total angle between P and Q is 135 degrees. If 135 degrees is the angle between them, and I'm to find P plus Q, then it means I have to find the resultant of this. What will be the resultant? This plus this. Okay, the arrows follow that order limit. All right, so the resultant will be in this direction. When you draw a vector from the tail of this to the head of this will be the resultant R. Okay, because from the triangular law of vectors, this plus this must be equal to that. So R must be equal to P plus Q. Please, are we okay? Are we okay here?
You say there, please, the angles.
The angle, you see, this is Q is 4 units, okay, in the direction south of west, and precisely south of west divide the quadrant into 2 equal parts. If you are giving such an information, it means the vector divides the quadrant into 2 equal parts. Okay.
Yes, please.
So if it is acting here, this is 45. This is already 90. So 90 plus 45 is the angle between P and Q. All right.
Yes, please. Thank you.
All right. So if that's the angle, then R squared is equal to 3 squared plus 4 squared. Okay. Minus 2 times 3 times 4 cos of the angle 135. And now direction. Direction. The direction of the resultant is this. The angle is made from the north, alpha. So sine rule. Are we fine?
Yes, Mr. Edgar.
Another way of doing the same thing is that, okay, I think because some of you didn't treat vectors at school, I have to look at resolution of vectors with all of you, else you will miss this part. For S8, 4, and those classes that I did, you've gone through this, but the rest of you, perhaps you didn't treat vectors at home. So let's go through the whole thing. Resolution of vectors into components. All right. Okay. So can I print it?
Yes, please.
So resolution of vectors. Resolution of vectors into components. A single vector, any single vector can be resolved into vertical and horizontal components. So every single vector can be resolved into vertical and horizontal components. So if I give you a vector, and the vector is along any of this is north, south, east, west. Example, if the vector is along maybe F1, a vector F1 is along the x-axis, and I'm to resolve these vectors into components. Every single vector can be resolved into components, two components, that is the vertical and the horizontal, or the horizontal and the vertical. And this is often represented as how we do on the Cartesian plane. You see, in your geometric transformation, when you are given a point within the Cartesian plane, y and x, you are to indicate the coordinates, x and y coordinates. Okay? The coordinate system. That is what we mean by resolving a vector into horizontal and a vertical component. So once the vector is along the east or x-axis, what it means is that this vector has a horizontal component which is x and no vertical component. So if I'm asked to represent this into component or in a coordinate system, then it means x and y would have to be, you see, F1 is lying on the x-axis. So when I measure it from the origin, this can be a certain value, okay? So from here to here can be any value. So it means this vector has a horizontal component of F1, the full magnitude of the force, but it has no vertical component, 0. In the same way, if the vector is along here, x axis, but the negative, maybe F2, and you are to resolve this into vertical and horizontal components. Okay, the x and y component of this will be, you see, it has horizontal component line on the x axis, but there's no component vertical. So x component is actually F2, but y component of this is 0. But you look at the direction of the vector. Is it to the positive x or negative x? This is to the negative x, so you have to bring the negative. So the component of this is negative f and 0 vertical. The component of this is f2, positive f2, because it's along here, and 0 vertical. Please, are we fine?
Yes, please.
If the vector is here, maybe f3, and you have to resolve this into vertical and horizontal components. Linda, how would that be? Help me. If we have f3 and it is along the north or y-axis, and you are asked to resolve this into vertical and horizontal components, what will it be? Linda. The same trick as I said earlier. Okay, let's have Carol to share her view with us. Carol, time.
Mr. Edward, please the question again.
We have F3, and you are asked to resolve F3 into vertical and horizontal components. What would be horizontal component X and vertical component Y?
Its X will be 0.
So 0.
Then
the Y
F3.
F3. Is it
Which is
positive?
Positive.
Exactly. Remember, we have F4 here. Resolve this into vertical and horizontal components.
Mr. Adia, please, the x will be equals to 0 and the y will be negative f4.
Correct. So that's all. So please, when a vector is along any of the axes, do not resolving it into component is this simple thing. Okay. Now, when the vector is in between, isn't on the axis, but it's in between. So we have this vector fx. Okay. F. It makes an angle theta with the y-axis. The question is that resolve the vector f into its vertical and horizontal components. Now, once it is in between, once the vector isn't lying on the x, neither on the y, it means it will have both x and y components. Okay. You see, it makes an angle theta to the y. What angle will it make with the x? If it makes theta with the y, what angle will it make with the x?
90 minus theta.
90 minus theta.
Go 90 minus theta. So you can use both angles to resolve this into the vertical and horizontal component. Let's start with 90 minus theta. Then, okay, let me change 90 minus theta to alpha. And are you there?
Yes, please.
Yo, Matthew. So the angle this makes with the x is alpha. It makes an angle of theta to the y-axis. And we are resolving this into components, x. So let's start with the angle it makes with x. It means let's have this to be the vertical component of this force Fy. And that direction will be here. And this as Fx to be the vertical. And then, so all that we are doing is that, yes, we are looking for x and y component, which will be equal to Fx and Fy. But we want to have the expression for both Fx and Fy. So that's what we are doing. If we use alpha, okay, this is the side adjacent to alpha. The side of the right angle triangle that is closely touching the angle adjacent. Now, a line drawn from the adjacent perpendicularly to it obviously will give you the opposite. So there's the opposite side. So sine of, if you are looking for the opposite, sine of the angle alpha must be equal to opposite, which is Fy on the hypotenuse F. Right? Therefore, Fy is equal to F sine alpha. And it's Fy is along the positive y-axis, so it's a positive. So this becomes the vertical component of this force F. Fy is F sine alpha. Let's look for Fx. Whenever you are looking for adjacent, the obvious trig ratio to use is the cosine, because cosine is adjacent over hypotenuse. Don't forget here you have the hypotenuse and the angle, so you have to use cos of the angle to get the adjacent. Are we fine? If you have a question, quickly ask before I continue. If you have any question. Okay. If no question, then let's continue. So if you take cosine of the angle, cos of this angle, which is adjacent Fx over the hypotenuse, which is F. Hello? Hello?
I was not asking a question. I was just helping you.
Okay, so Fx, we make Fx the subject, is equal to F cos alpha. F cos alpha. So we have the horizontal component Fx, we have the vertical component Fy. Therefore, let's put it there. This is equal to F cos alpha, and Fy is F sine alpha. This is the resolution of the force into component using the angle it makes with the x. Are we fine?
Yes, please.
And here too, you look at the quadrant. Is it positive? Does it fall within the positive or the negative? we take them into account. Let's use the angle it makes with the y. Please, if you are writing quickly, copy and so I can clean this part. Okay, let me use this side of the board. We are using the angle it makes with the y. And this is the angle. The side that already touches the angle becomes the adjacent. So this side becomes the adjacent. And when we draw a perpendicular line from the adjacent, that perpendicular line to the adjacent becomes the opposite. So when you draw a line from the adjacent, because the line is perpendicular to the adjacent, it becomes the opposite. So this is the opposite side. Now you realize that the adjacent side of this angle falls within falls along the y-axis. It falls, this is the y-axis. This is the x-axis. Okay. The adjacent side falls within the y-axis. So this side will become fy. Fy because that side, which we are calling as the adjacent, falls along the y-axis. This side, which is the opposite to the angle, also falls within the x-axis. This length is the same as this length. And because this side falls within the x-axis, it automatically becomes fx. Please, are we fine?
Yes, please.
Okay. If this is fy and this is fx, then using this angle, because this is the adjacent to the angle, when you are looking for fy, you have to use cosine. It means you have the angle and then the hypotenuse. And this is adjacent. So cos of the angle, by this time, this angle theta will be equal to fy on the hypotenuse, which is f. Fy therefore is equal to f cos theta. This side is the opposite. So when you are looking for opposite, you have to use sine. Sine of this angle theta, which is equal to opposite fx on hypotenuse. Fx therefore is equal to f sine theta. So it means that if we are resolving this force F into components using this angle it makes with the y, the component x and y component will become f sine theta to f cos theta. And look at the similarity. When you are using the angle it makes with x, okay, the component becomes cos sine. When you are using the angle it makes with the x-axis, the component becomes cos sine. If you are using the angle it makes with the y, the component becomes sine cos. That's the difference. But both situations must give you the same results. Are we fine?
Yes, please.
All right. So I think we've done 2 hours. It's 6 o'clock exactly. Do we continue or end here? We've done 2 hours.
Please, we should continue.
Is it unanimous to all of you? So let's do about 30 minutes. Is it unanimous, agreed by all of you?
Yes, please.
Okay.
Yes, please.
So let's take an example. A force of 100 Newton. We have a force of magnitude 100 Newton acts at an angle of 60 degrees to the x-axis. Determine the components of this force. So we have a force of 100 Newton acting at an angle of 60 degrees to the x-axis. We are to determine the components of this force. If you are done planing, writing this part, can I plane it? Yes.
Yes, please.
Me and my answer put it. So let's first draw it. We said the force is to the x-axis. So this is my x-axis, an angle of 60 degrees from it. This is 100 Newton, 60 degrees. But if this is x-axis, then it means the remaining angle it makes with the y-axis. The remaining angle it makes with the y-axis is 30, correct?
Yes.
Okay. So we are going to use both the angle it makes with the x and the y for the resolution, and we need to have the same results. We need to have the same results or answer. So when we use x, this is the adjacent, and a perpendicular line to the adjacent gives us the opposite. So this becomes fx, this becomes fy. When we use the angle it makes with the y, this side becomes the adjacent, and this a perpendicular line to the adjacent would give us the opposite. So this is fy because it's along the y-axis, and fx because it's along the x-axis. So using this, fx for 60 is equal to fx on 100. Fx is equal to 100 cos 60. Sin 60 is equal to opposite fy on 100. Fy is equal